Hi everyone, I'm Karthik. I principal solution architect with Kinetico. So we'll talk today about GPU accelerated database. So a show of hands here, how many of you are familiar with GPUs today? Oh, okay. Can you hear me now? Sorry about that. So I see around 5, 6 hands go up. So, and how many of you are using GPUs today in production? No? Okay. So what I'm going to do today is talk about how GPUs can enable you to solve complex analytics and what GPU brings to the AI world today. So in the interest of making it interactive, I'm going to limit myself to 3, 4 slides max, right? And then we'll go directly to demos, right? The challenge is I'll have to hold the mic and do the demo, so it might be a little bit tricky, but hopefully we'll manage it, right? So just give you a couple of introduction slides on what the company is, where we came from, and then we'll go into a demo. Okay, so the company is called Kinetico, right? So this was founded back in 2009, and it was incubated as part of the US military. So the goal was to determine terrorist threat activities, identify alerts, identify opportunities in different data sources that come into the United States Army, right? So they had 200 different data sources. They had billions of rows. Basically, they had rows of time-based data. They had weather information. They had information from various agencies across the world. And the need was to correlate the data and to find out nuggets of information that could be helpful to the US Army. So at that point, General Keith Alexander started an in-house project where they could take the in-house resources. Our founders, Amit and Nima, started out an in-house project based on GPUs to accelerate some of their analytics, right? So it started in 2009, and in 2012, we decided to go come out and become commercial about it. So that's where GPU started. The company was initially called GPUDB, and last April, we changed the name of the company to Kinetico. Right? And the second slide is this, right? So what are the advantages of using a GPU database? Now, a GPU itself, for all those who have worked with GPUs, has an ordinary GPU has anywhere from 4,000 to 6,000 cores, right? CPU, we have anywhere from 2 cores to maybe 40 cores. Recently, Intel has come out with this new version which has 100 cores, but that's the amount of cores a CPU has, right? So we actually have a T-shirt. We're not giving out T-shirts today, but we have a T-shirt that says, "Don't send a CPU to do a GPU's job," right? So what we can do is to leverage all of these cores and enable parallel processing using the GPUs, right? So that's the power of the software. What we've done is we've built a database on top of that, and we've exposed it to the outside world for using any language of your choice. So traditionally, GPU developers are CUDA-based developers, right? So obviously you can use CUDA, but let's say if you're using Python, you're using Java, you're using Scala, you're using let's say C++, you can use these programming languages and leverage the power of GPUs, right? So we'll see how to do that. So with that said, I'm going to go into one more slide and then demo, right? So what are the strengths of Kinetico? So Kinetico, at the end of the day, has 4 unique strengths, right? So we are a very fast distributed database engine. So that's fast OLAP. So if you want to perform any queries in a fraction of the time, you can do that. I'll show you how that's being done. We have an ability to supercharge your BI. So if you're using Tableau, Power BI, any BI tools that needs acceleration, Kinetico helps with that. We have a native geospatial feature. So our background in the US Army enabled us to build a very heavy geospatial feature, WMS, WKT, geospatial points. If you want to have a geofence and perform analytics on that, we support all of that. And finally, what we're going to talk about today is the convergence of AI and BI, right? So if you want to take your machine learning libraries, if you want to run, TensorFlow code, H2O, bit mark, right? If you want to take your machine learning libraries and run them on Kinetica, parallelize them and accelerate them, you can do that with the product as well. And I'll show you a brief demo. So with that said, let's skip the slides. I have around 18 slides, but I'll probably go back to the architecture on how it works towards the end of the presentation. Let's go to the demo. Okay, so what I have here is, yeah, so I can't see the board very well, so hopefully the font is good enough. Okay, so what I have here is a cluster that has a 8-node Kinetica cluster that's on super micro boxes. Now you could have your commodity hardware, right? So you could have it on Cisco, IBM, HP, Lenovo, whatever hardware of your choice, right? So you have an 8-node cluster. Right now this has around 1.5 terabytes of data and around 25 billion objects in it, right? 25 billion objects. So more specifically, if I look at the tables, so these are my collections. So this table here has 4.1 billion records, right? So this is a streaming table. So if I refresh this guy, you can see that it's increasing. And before the demo, it's actually going to hit 4.1 billion, right? It's 4 billion 99 million. So another, very quickly on the data itself. So this is how the data looks like, right? So you have your basic, it's like any other database, right? DB2, Oracle, whatever. So you have your columns, you have your types, string, int, long, etc. And you have your properties, right? So you have concepts like primary key, foreign key, text search. You can store it in different tiers. You can store it in your GPU memory. You can store it in your system memory. You can store it on your disk. But you have all of these components here, right? So the two key things here. This data is not indexed, right? So you can specify indexes, but it's not indexed today, right? So any queries, any analytics that I perform on this is going to be a brute force table scan, right? There's a brute force table scan on a table with approximately 4.1 billion records. So no indexes, and then the other key thing is no primary key, no foreign key, right? So it's you can set it if you want to, but for the purposes of this demo, it's not there, right? Another view of this data is via this screen here, right? So this is these points mapped onto a geospatial map. So just to show you how fast it is, I'm going to refresh the screen and let's see how fast it comes up. So I refresh the screen and then I click on this button, the tweet button. So this paints 4.1 billion entries in a few milliseconds, right? And then if I hit the live update button, you can see those live tweets coming in as we speak, right? So let's perform some analytics on this, right? So let's do a geospatial filter, right? And let's find out let's do a freehand polygon, right? So let's choose a little bit of Eastern Canada, Eastern United States, cover Florida, and that's my freehand polygon, right? There we go. So now you're able to boil down from 4.1 billion tweets, 4.1 billion rows, to 736 million rows in a few milliseconds, right? And just to show you that I'm not caching this, and this is being performed on the fly, I'll go to the back end and I will show you the data, right? So I actually have a filter here that has this result set right there, 736 million records, right? So it's right there. Right now, let's perform a text search on this, right? A text search on 736 million records with no indexes, no primary key. So let's search for any volunteers. Let's search for KAYAK, right? Thanks to them for hosting this, right? So let's search for KAYAK and see how many people are tweeting for KAYAK, right? So, but this comes up with obviously KAYAK, the company, and also KAYAK, the boat. So there we go, right? So some of them are not fit for work, but some of them are. It has the word KAYAK in it, right? So, but the important thing is you can see that it came up in a few milliseconds. Right? So this is so we are now able to boil down from 4.1 billion records to little less than 25,000 records. And just to show you very quickly the back end, if I refresh this guy, you'll see another. So it's query chaining, right? So you'll see another filter with 25,000 records, right? So queries are very, very fast. And this is because all of this is offloaded to the GPUs, right? So two things we've seen. We've seen the geospatial filters. We've seen text search, NLP type text search. Let's move on. Let's go to SQL queries, right? So let's perform some SQL queries on this very quickly, and then we'll move on to other stuff. So this is a table. This is a table scan, right? So I'm doing multiple operations on this table: count, sum, min, max, average, standard deviation, variance. We have our documentation that's public, kinetica.com/docs. And if you go to functions, this talks about all the functions that's supported, more specifically aggregates. These are all the aggregates that's supported. I chose a few of them from here, and I put it out there. So this, when I hit the run query, it runs a table scan and performs the variance, standard deviation on a table with 4.1 billion records. And this completes in 70 milliseconds, right? So no indexes, no primary key, no foreign key, completes in 70 milliseconds, right? Just to show you it's not cached and it's streaming data, right? So let's perform this query again and see if the numbers change. So the count ends in 159, right there. If I run this again, it completes in 74 milliseconds and it's 256. So when while I was talking, we got around 80 tweets, right? And we have this free Twitter feed, so it's like it's a very, very small amount, right? You have to pay for everything nowadays. Okay, so that's one query. Another query with the between clause, right? A little more complex query. Had a where clause and between clause on 1.1 billion records. So it does table scan, where between clause. This is 21 milliseconds. And then I wrote a little more complex query that does a lot more things. So this does an average, a count. It does a join between two tables, around 20 million records, right? Not a lot. 20 million is still a lot for some use cases. Does a join based on the ID, and does a wildcard search, and does a group by, right? So wildcard, group by, joins, table scan, average and count. This one runs in 56 milliseconds, right? And again, so the reason is it's backed up by the GPUs, right? Okay, so that's from a query perspective, right? So let's move on. So let's go into the 2 minutes on the architecture, and then we'll talk about how we execute any ML libraries, AI on Kinetico, right? So. Okay, so the architecture is like any other in-database architecture, right? So it's distributed. It's we have a persistence layer. It's durable. So this talks about a 4-node cluster, right? So you have 4 nodes. Every node has a concept of a HTTP head node. So you have a concept of multi-head, multi-thread parallel ingest. So just this morning, we enabled the parallel ingest, and I was able to ingest 10 million records per second using one of our internal clusters. We were able to achieve 1.4. So we were competing with other in-memory databases for Walmart, which is a public reference, one of our biggest customers. So we were able to get 1.4 billion records ingest per minute. That's the average. Peak 4 billion records per minute using a 4-node cluster, using a 10-node cluster, multi-head ingest. One of the key things about the software is you don't need CUDA. You don't need to know CUDA to program on GPUs, right? If you know CUDA, great, right? So that's more power to us. You can still use it. You can leverage the GPUs. But if you are a Java, Python, C++, C user, you can use the software as well. And just to quickly break from here, go back to our documentation, kinetica.com/docs, one of my favorite websites. You go to API reference. That talks about the various API, what it supports. Is pretty comprehensive. I've used C++, I've used C, I've used Java, I've used Python, obviously, right? And then the rest, right? So just let me click on one of these. So this has a comprehensive API set. You can go through this whenever you would like to. Let's go back to the architecture. Quickly cover a couple of points. Okay, so we have integrations with all of these APIs that we spoke about. Close to 70% of our company came from a Hadoop ecosystem, right? My manager from Hortonworks, my the head of sales is from Cloudera, MapR. So we have an extensive integration with the Hadoop ecosystem, Spark, Storm, NiFi, Kafka, all of the good stuff that's out there, right? Extensive integration with visualization layers. So we have Tableau. Tableau is 100% certified. All you have to do is create a JDBC data source, point to Tableau, you're good to go. Power BI, MicroStrategy, and then we have an extensive geospatial features that I'm not going to get into for this discussion. Okay, so one more quick demo, and then I'll move on to, okay, and then we'll move on to the UDF piece. Okay, so what I have here is 1.1 billion rows of data of taxi information that was started in the New York region, right? So slicing and dicing the data for any ML type of workloads, any AI type of workloads, slicing and dicing the data based on different dimensions is very, very important, right? So let's quickly try and see how fast it is with this data, right? So let's choose vendor NYC. So just an FYI, these dashboards, there's plenty of math behind these dashboards, right? So the taxi table, so the query behind that is you group by vendor, you do the average cost. This is a group by payment type, total sum. So there's a lot of math, a lot of beefy math behind this. So when I click on something on the dashboard, all the other dashboards are going to update. So there's multiple queries going on behind the scenes. So let's choose NYC, right? You're going to now boil down to 40 million records from 1.1. Let's choose cache. Let's choose a timeline, right? So there's plenty of work going on in the back end. And then let's choose a geospatial region here, right? So now you're able to boil down to around 2.8 billion records, 2.8 million records from 1.1 billion, and you're able to do this very, very quickly. Now, for any machine learning type operations, you have to rinse and repeat, right? So you have to repeat this calculation again and again with different data sets and try and get some insights by running with multiple search criteria, multiple feature sets. So what we are capable of is, let's say if you want to run the same search with the same vendor, the same payment type, but keep a different geospatial region. So all you have to do is say edit and then move this across maybe to the Upper East Side region, right? So it's going to rerun the same calculations with the same vendor ID, with the same payment type, and now you have 1.5 billion records, right? Let's say you want to edit the region to a larger circle, you can do that as well. But you can see that calculations are instantaneous and things move very, very fast, right? So with that said, let's move on to another aspect, another key aspect of the software, and that is the convergence of AI and BI, right? So one of the other things that Kinetico allows you to do is to provide you with a concept called UDF, right? So your UDF is a user-defined function. So you can take any of your functions, right? It could be something simple like a linear regression function. It could be a value at risk calculation. It could be volatility calculation. So I was working with a bank that wanted to take their risk calculation, credit card risk calculation. They usually run certain models that determine which customer they can give a credit increase to. So they have, obviously, even banks have a limited amount of money. I was surprised when I heard that. But when they want to give a credit raise to certain people, certain individuals, they hedge their risk, right? So they give it to people who traditionally have a revolving balance so that they can get most bang for their buck, right? So they run certain models on it. So what we are able to do is some of these models take anywhere from 6 hours to run individual models, and then if they run in parallel, they can take anywhere from 12 hours to 2 days. So what we were able to do is take these models and deploy them as a UDF within Kinetico. So it's a user-defined function. It's your compute. Take your compute, package it, deploy it in Kinetico, use the parallel processing of the GPUs, and also offload it to the GPUs, and call it using Python, using C++, using Java, using any custom functions you want, right? So the data preparation and the data models would reside in Kinetico, and now you can serve up your models in a fraction of the time, right? So to quickly demonstrate that, what I have here is, what I have here is, let's go back to our dashboards here. So I have new car sales. So what I was able to get is new car sales for the country of Norway, of all countries, right? So I couldn't get new car sales in the US. So I got it for Norway from one of the websites, right? So obviously, you can slice and dice the data very fast, right? So we've seen that. So let's quickly choose, Ford, right? So they have a model called Mondeo. So I don't know if any of you own a Ford Mondeo, but let's look at the sales of the Ford Mondeo, right? So this, if you look at the sales, it's constantly, well, it was pretty good back in 2008, but in 2013 and 14 and 15, it kind of bottomed out, right? So what I have here is a linear regression algorithm. So let me show you that. So that's a user-defined function. So for another way to look at user-defined functions, it's like a stored procedure, right? So back in 98, when I started out, you have the concept of stored procedure, compute to grid, right? Get your compute, put it on your grid. So this is stored procedures, but in a distributed way in memory where your data resides. So I have here two algorithms for today. I'm just going to go with the linear regression, right? You can, if you're a power user, you can add stuff here. You can specify your name. If you have five operations that need to go into your function, you can specify that there. You can run it here, right? Execute it there. You can do all of that good stuff. However, you can also do it from the dashboard, which is what we're going to do today. So I chose Ford, I chose Mondeo, and then let's do a linear regression algorithm and predict the future car sales for the next 2 years based on the last 10 years of data. And let's sort it by month, and let's see what the sales would be. So let's sort it by month. As you can see, it's very, very fast. So this basically predicts that for the month of 1, which is January, the average sales is 247, but it's reduced, right? So you can actually see that in 2019, they're just going to sell 32 cars. Then if you go further down, you can see for the month of July, they're going to sell 0 cars. So obviously, it doesn't make sense for Ford to invest in the Ford Mondeo, right? Let's do the same thing for something that's a little more positive. The Volvo, right? So the Volvo XC60. So one of my colleagues told me that in the UK, the Volvo XC60 has some seatbelt problems, right? So it looks like they recalled some cars, but it doesn't seem to have affected their sales. So again, you sort by month, you can see that the average sales is 177 per month. But based on our linear regression algorithm, we were able to predict the car sales for the next 2 years. And for 2018, it's 236. For 2019, it's 245. So obviously, sales are growing up. So you can probably make a decision to invest more in this, get some better seatbelts, right? Okay, so with that said, I have 4 minutes left. So I'm going to stop. A couple of quick things. So we have a raffle going on. We're going to give away a Google Home. So for those who haven't put in your business cards or written your name, so we have a fishbowl in the reception, and we also have an ebook that's out there in the reception as well. I know some of you already have it. So if you need to know more about GPUs, how it works, then you can read about it in the ebook. So with that said,
yeah, thank